Welcome. The topic we'll be discussing in this lecture is abstract data types. Okay. So in the last two classes, we have discussed about the introduction to pointers. As the course proceeds also, whatever the pointer concepts requires, we'll touch upon that. But now we'll continue with the data structure aspects. So in this session, we'll be discussing about a concept called as abstract data type. Okay. So before defining abstract data type, let us try to first define what is a data type. Data type is a collection of objects and set of operations that can be performed on that. So if you take an integer data type, it's a collection of what? It's a collection of numbers within certain range. Okay, the integer, it has a range, right? So whatever the range. So for example, in C, if you take a character data set, character occupies the 8 bits. That is the memory required for a character is the memory, the size of the character data type is 1 byte. It is 8 bits. Character is also, it's one form of integer. Character is also one form of integer because if, say for example, if I'm defining a character variable, character C is equal to 50. If I assign 50, then what will happen? There will be an ASCII value associated with 50. It means that is assigned to C. Okay. So character is also one type of integer, but it is an 8-bit integer. Okay. So if it is 8-bit, the minimum value it can take is -128 and the maximum value is 127. Right. Like that, for every data type, there will be a range and then what operation you can perform on the data type. So normally if it is an integer, you can perform addition, subtraction, division, all these things. Okay. So this is how we define a data type. A data type is a collection of objects and a set of operations that can be performed on it. Right. Now let us try to understand what is meant by an abstract data type. So an abstract data type is organized. An abstract data type is a data type which is organized in such a way that the specifications of the object and the specifications of the operations on the object is separated from the representation of the object and the implementation of the operations on the object. Okay. So what does it mean? See, there are two words which is important. Here there are two words which is important. One is specification and the other one is representation or implementation. Okay. Representation or implementation is both are same. Okay, fine. So these words are important. So basically what an ADT, abstract data type, does in the sense, so abstract data type is a data type which is organized in such a way that the specification of the object and the specification of the operation performed on the object. Okay, the specification means what is the specific, how you specify that particular data type. If it is a float, then it ranges from this value to that value, like that, the specification, and what operations that can be done on the data type. You are specifying using some means that these are the operations that can be performed on this particular data type. Okay, so that is called a specification. And representation of the object and the implementation of the operation means how this object is represented in the using a particular tool, that is a programming language. Using a particular programming language, how it is represented, that is internally in memory, how it is represented, and how these operations are implemented. Okay, so the point is, an abstract data type is the one which separates the specification from the representation or implementation. That is what In short, you should understand. An abstract data type is one which separates the specification and implementation or representation. Okay, so why it should be separated? Yeah, so why it should be separated in the sense? It should be separated because specification of the object and the specification of the operations performed on the object are from user perspective. Okay, these are from the user perspective. So a user, what he want, a user who is using a particular data type, what he want to know what is that particular data type, what does it mean, what are the typical values it can take. So that is called a specifying that object. Okay, and specification of the object and operation and specification of the operation, and also he want to know what are the typical operations that can be performed on the data type. From the user specification, the user needs only these two information. That is, he want to know how this object is specified, that is what does the object means, and then what are the typical operations that can be performed on this object. If he knows these two things, he can comfortably use this data type wherever he want. Okay, but the user is not bothered about the representation of the object and the implementation of the operation. That is how this object is represented in the memory. This particular object occupies how much bytes of memory, or whether it will take memory continuously or discontinuously, and whatever the operation it supports, how it is implemented. All these details the user don't want. Okay, so an ADT is one, an abstract data type is one, which is organized in such a way that the specification of the object and the specification of the operation performed on the object are separated from the representation of the object and the implementation of operation on the object. Okay, because these two are different things. From a user perspective, he needs only the object specification and the operation specification. He is not bothered at all about the implementation details of the object and the operations, right? Okay. So how specification differs from implementation? So that's what previously we have discussed. So specification is important from a user perspective. So user needs only the specification details. What is this data type? What it can do, and what are the operations? Okay, what is the range or something like that is the user needs only what is the use of that particular data type and how it is to be used. Only this much the user needs. The user don't want any detail about the implementation. Okay, so that is what the ADT does. The ADT separates the specification details of the object from the implementation details. Okay, so what are the typical specification details of an object? The typical specification detail of an object or function description, which means a description like what this particular data type will do, why it is used. Okay, description means what is the use of this data type. So if you take integer, so integer is a data type. Using this, you can create an integer variable which can be used to store a whole number. It can be a negative number or a positive number. And starting from what range to what range. What is the negative most number you can store, and what is the maximum positive number you can store. So that is called as description. And then what are the operations that can be performed on this particular data type. So for different operations, there may be different functions available. So the names of that particular function, and each function may take some argument, okay, and it may return some result. Okay, so these details, so specification includes all these things. Specification includes function description, which describes that particular data type or the object, and for each of the operations that can be performed on this particular data type, the specification includes the name of the function, the number of arguments and the type of arguments it takes, and the result type. If you perform the operation, what type of result it will return. I mean the resultant data type. Right? So in a simple case, assume that you have a data structure called stack. Assume that you have a data structure called stack. Okay. So the function description will be A stack is a data structure which is used to perform something called as first in last out, or lost in first out. That is, whatever the data you push in the stack last, that will be the one which will come out first. Okay, and whatever the data that you pushed into the pushed first into the stack, that will be the one which comes out last. So this is the function description for the stack data structure. Okay. This is the function description of stack data structure. And function name. What are the typical function a stack data structure will have? It will have it may have a function like is empty. Is empty. So this is a function which will say whether the stack is currently empty or not. Okay. So it will say whether the stack is empty or not. So this is the name of the function. Does it take any argument? No, it does not take any argument. What it returns? It will return a Boolean value. It will return a Boolean value, true or false. Yes, it will yes or no. Okay. Similarly, it may have a function is full. So this will say whether stack is full or not. So does it take any argument? No, there is no argument. What it will return? It will also return a Boolean value which says whether the stack is currently full or not. If it is full, it will return true. Otherwise, it will return false. Okay. And then maybe a function called push. Push. It may take one object as input. Okay, depending on the stack type. If this is a stack to accept integer value, it will take one integer as input. Okay. So let us keep as generic some object as input. Okay. It will push that object into the stack. Does it has any return type? No, it just performs the operation push. Okay. So it may have a function called pop. It will return the whatever the data that is available in the top of the stack. So whatever the thing that is recently pushed, that will be popped out. So what it will return? It will return that object whichever it is popped. Okay. So this is how abstract data types are represented. So an abstract data type will have a description of that particular data type, and it will have all the functions, what are the various functions, what are the arguments it takes, and what is the return type. Okay. And ADT, the abstract data type, does not bother about the implementation. It only bothered about the specification. The abstract data types only specify that particular data type. Okay, this is how the data type should behave, like that. How it is implemented, that is not, we are not bothered about that, because implementation may vary from programming language to programming language. Integer might be implemented in one style in C. It might be implemented in some other style in Java. Totally, it might be implemented in some other style in Python. Okay, but the abstract data type of integer will be always more or less same. So the ADT is not dependent on implementation. So just now we have discussed that an example ADT for stack, where there are functions like push, pop, all these things. A typical ADT, abstract data type, will have three types of functions. What are they? It will have a creator or a constructor function. It will have a creator or a constructor function which is used to create a new instance of the particular data type. New instance means one variable of that particular data type. Transformers. So constructors or functions which is used to create a new instance of that particular data type. So for example, stack we discussed. Okay. So if you want to create an instance for a stack, okay, maybe in a typical programming language, you may have to write like this, stack yes. So now what does it mean? Yes is an object or an instance or a variable of type stack. Okay. So when you say int a, what does it mean? What does it mean? A is a object or a variable of type int. So that is a new instance. A is an instance of type int. Okay. So this statement is nothing but a creator This is a creator statement, okay, even though it's not a function, okay, but typically it will be implemented as a function, okay. If you take programming languages like Java, then stack might be implemented like this: stack s is equal to new stack, okay, new stack. So now what happens? So whenever you say new stack, so it means there is a class called stack, the respective constructor will be called, okay. So that's what it says. So there is a creator or a constructor function which is used to create a new instance of the designated type, okay. Transformers are used to create an instance by using other instances, okay. Transformers are used to create an instance by using other instances, okay. Say for example, you have already created a stack s, so we know that s is a stack. Say for example, here I am doing some push operation. Let us assume these are typical statements in Java, okay. For simplicity I am taking Java as example. S dot push of 10, so this will push 10 into the stack, okay. So then I'm saying s dot push of 20, so this will push 20 into stack. So it means that I have a stack which contains these two values. uh, uh, the the value that is first pushed is 10, the value that is next pushed is 20, okay. So say that now I want to create another stack which is just a copy of s. So then I can create like this. If the particular programming language supports stack a, so a is a new stack. Stack a is equal to new stack of s. I can say that stack a is equal to new stack of s. So what does it mean? It means that a is a new stack, but it is same as that of s. A is a new stack, but it is same as that of s. So this is stack s, but a is also similar to s, because but that is a also contains whatever s contains. So s contains currently 10 and 20. So a also holds these two values. Okay. So in that case, now this becomes a transformer function, because it has created a new instance by using other instance. So a new instance A is created by using the instance S. Okay. And also the other type of function you may have is observers or reporters. They don't modify the stack. This observer or reporter function, they won't modify that particular object, but they will provide information about the instance of a particular type. Say for example, is empty, we have discussed previously, is empty. This function will never modify that object stack. It will just say that whether stack is empty or not. Similarly, is full. It will not change the content of the stack. It will just say whether stack is full or not. So just it will say true or false. So such functions are called as observers or reporters. So a typical abstract data type will contain these functions. Creator, which is used to create a new instance of that particular designated type. A transformer is also used to create an instance by using other instances, and observers or reporter, which is used to provide information about the instance of a particular type. Okay. Here is an example for the abstract data type. The abstract data type here we are taking is natural number. So natural numbers are numbers which is starting from 0 to all positive numbers, actually comes under natural number, right? But if you want to implement this in any programming language, you cannot go up to infinity. There will be some limit, because actually the limit is based on the memory allocated for the particular data type. So for the natural number, if you allocate only 1 byte, you can only store up to 0 to 255. Okay, because all 8-bit is 1 means it is only 255. Okay, so if you allocate 2 bytes, okay, then you can store 2 to the power uh, for allocating for natural numbers. If you allocate 2 bytes, If you allocate 2 bytes, that is 16 bits, okay, then you can store values from, then maximum you can store 2 to the power 16 values. Okay, that is from 0 to 2 to the power 16 minus 1. This many values you can store. Okay, this is the range. This is the range. Range is 0 to 2 to the power 16 minus 1, whereas the number of values that can be stored is 2 to the power 16. The total number of values that it can hold is this many values, max 2 to the power 16 values. Okay, so actually it depends on the number of bits that is allocated. So if there is n bits, then maximum it can hold 2 to the power n different values. So this also can hold 2 to the power 16 different values, which ranges from 0 to 2 to the power 16 minus 1. Okay, you cannot say that there will not be any limit. The actual definition of the natural number is 0 to infinity. Okay, but when you implement, it will have some max. So that max number we call it as int underscore max on the particular computer where you are implementing. So first, what we are doing, we are just if you go back to the previous slide, the specification includes what? Function description. First, we are describing what is meant by an abstract data type. So this is how it is described. An ordered subrange of integers starting from 0 and ending with a maximum integer on the typical computer. And then what are the functions it supports? Okay, it supports these functions. And this is some preliminary we are writing for that. For all x comma y, okay, if x belong, for all x comma y, if x comma y belongs to NAT underscore number, which is nothing but natural number, okay, then and true or false belong to Boolean. So these are some of the things we are declaring. That is, if say that there are two numbers x1 y which belongs to natural number, and true or false belongs to Boolean, and plus, minus, less than, and equal to are the operations that we can perform. Then assuming that these are the functions, these are the typical functions this particular abstract data type may support. Okay, so what is the first function? 0. So this 0 is the name of a function. Okay, this function will return the natural number 0. Okay, it will return the natural number 0. So what it will return, its return type is one natural number. So NAT underscore NO, that is the return type. Its return number, it's a natural number. Okay, there is another function is 0 of x. This returns a Boolean value. So what this function will do, it will check whether x is if x is 0 or not. If x is not 0, then it will return false. Okay, so if you say just if x means, then it means that x is a positive number. Okay, so if x is true, then it will return false because it is not 0. Else it will return true because it is 0. So it is used to check whether x is 0 or not. Okay, and this function add x comma y, it will add two natural numbers and it will return. But before adding, it will check, it will ensure that the sum is not exceeding int underscore max, because this is the highest natural number you can specify. So your sum cannot go beyond int underscore max. So what this function will do, it will check, it will perform x plus y. If x plus y is less than or equal to int underscore max, it will return x plus y. Otherwise, it will return int underscore max, which is the maximum or the highest natural number. Okay, so it returns a natural number. Equals x comma y, it checks whether two natural numbers are equal or not. If x is equal to y, it returns true, otherwise it returns false. Successor of x, it will return the natural number which comes after x. Okay, so here also it will check if x is equal to int underscore max, the maximum, the highest natural number, then it cannot return any successor. In that case, it will just return x. Otherwise, it will return x plus 1. So it checks if x is equal to int underscore max, it returns x. Otherwise, it returns x plus 1. then what you call subtract x comma y. So this is used to subtract this is used to subtract y from x. Okay, so that is we want to perform x minus y. Okay, so we don't want to perform and you can perform this only only if y is greater than x. Okay, you can perform this only if y is greater than x. If y is less than x, if y is less than x, sorry, you can perform this only if x is greater than y. Okay, you can perform this only if x is greater than y. Okay, if x is less than y, then what will happen? If x is less than y, then it will become a negative number and natural number stops at 0. Okay, so you cannot return a negative number. So suppose if x is less than y, then it will return 0. Okay, so x should be greater than y. So it checks whether x is less than y. If x less than y, it returns 0. Otherwise, it returns x minus y. So the return type is natural number. Okay, so this is the end natural number. So this is how the abstract data type is defined. Okay, so the abstract data type is not an implementation. It is not. It is here we are not implementing the data type in any language. It is the specification. This is how this particular data type is expected to behave in any programming language. It may be C or Java or Python or wherever it may be. Okay, these functions may differ. Okay, it is not that every programming language will implement the same functions. No, the functions may differ because in implementation, obviously there will be some changes. Okay, so with this example, I think you got some clarity about abstract data type. Okay, so abstract data type is the one which separates the specification of the data type and the operations from the implementation of the data type and its operation. Okay, so why it is important in the sense a user is more bothered only about the specification. He is not bothered about the implementation. So when you are learning the course lecture, it is a generic course. It is not connected with any specific programming language, right? We are learning it through C, but data structure is a generic concept. So we are discussing something called as abstract data type. So whenever we discuss any data types or any new concepts, we'll start with that abstract data type of that particular data type, right? So that is what I wanted to give an introduction on that. So I want you to try these things as homework. Add the following operations on natural number abstract data type. Predecessor is greater, multiply and divide. Okay, that is abstract data type has some functions, but to these you should add these functions also. Predecessor of x, which will return the predecessor of x. Okay, but before returning, you should check whether x is not 0. If x is 0, just return 0. Okay, and if x is greater than 0, then you can subtract 1 and return. Okay? Then is greater, used to check whether x is greater than y or not. Multiply, to multiply x comma y. Divide, to divide x comma y. So you have to write that appropriate functions and the logic like this. Okay. And then create an abstract data type called set. So set is a normal thing which you might have studied in maths or discrete mathematics. Okay, the set of numbers, right, or whatever it may be. You can define a set and you can include operations to create a set. Okay, create any. So you may include a function create that will create an empty set, right? And then you can use insert some values, which is used to insert one value. Okay, and then you can write functions to remove. So insert, you may use some condition, because before inserting you have to check whether that value is already there or not. If it is not there, you insert. Remove, you check whether the value is there or not. If it is there, remove. Is in, it will just check whether that particular value is in the set or not. If it is there, it will return true, otherwise it will return false. Union, to combine two sets. Intersection, so if you have two sets, combine by using the function union. So provide the abstract specification for the union function. Provide the abstract specification for intersection function. Provide the abstract specification for difference function. Okay. Similarly, create an abstract data type called bag. What is bag? Bag is similar to set, but it can have duplicate values. That's the only difference. Set cannot have duplicate values, bag can have duplicate values. And include at least these operations. Of course, you can include all the operations that is applicable to set, but minimum you should try these: create, insert, remove, and isin. Then create an abstract data type called boolean and include the operations and, or, not, and XOR. So I want you to try this uh, by specifying the abstract data type. So whatever you write, it should be of this nature, like how we defined here abstract data type. We have discussed an example abstract data type for natural number. Similarly, you should give the specification abstract data type for set, bag, and boolean. So first you have to give the description, okay, the function description, what it will do, and then the various functions. Fine. So please try it and update me. So let us stop here for this session.